So now let's go into the section 8.2, that is nothing but 8.2, that is principles of electrolysis. Principles of electrolysis. See, please remember one thing. See, you may not know now at this stage what is the industrial importance of electrolysis. In fact, in a world of electric batteries and electric vehicles, there are a lot of research and lot of things, it is getting started. It is getting started with the help of electric vehicles and battery. Okay, and many of the materials, so for example sodium, lithium, potassium, these kind of very reactive metals, it is getting invented, it is getting started with the help of electrolysis. The end products of electrolysis, it is mostly it will give reactive metals. Okay, so what the information, see what we need to know when electrolysis is happening. See, remember the word lysis. Lysis means breaking. For example, the electrolysis means with the help of electricity you will be breaking some molecules, or for some force of attraction between molecules, that is called electrolysis. For instance, you can see sodium chloride, see NaCl. So when you are passing electricity, so this will be broken to Na plus and Cl minus. Okay, so the force of attraction between this positive and negative charges, force of attraction between this Na plus and Cl minus, it is going to be broken. Okay, so this is nothing but electrolysis, right? And now we will go a little more detail into how the process is happening, and through where the electricity is happening, and through where the electric charges are flowing. So these things we can move into. So let's consider next one, lead bromide itself. Okay, so these are the points, or like a rod. We can say this is let it be graphite rods. Graphite rods, okay. Graphite rods, and this is going to be connected to the battery. So this negative terminal is connecting to this terminal. So this terminal, it is going to be negative, and this positive terminal you will be connecting to this terminal. So left to is a terminal. So this is going to be positive. Okay. So this battery, one positive terminal of the battery will be connected to this rod. Negative terminal of the battery is going to get it connected to this rod. Okay. And this solution, this is going to be, so this is going to be, okay, you can say lead bromide. Okay, okay, so what will happen actually when the electricity passes? See, when the electricity passes, actually this lead bromide, it is going to be split into Pb2 plus C, and so let it be, this is a molten lead bromide, not solid one, molten lead bromide. So this is going to be split into Pb2 plus 2Br minus. Okay, Pb2 plus 2Br minus. Okay, and yeah, and what you can understand, actually, see this Pb2 plus, obviously this is positively charged ions, right? So these are positively charged ions, what we call it as cations. Cations. Negatively charged ions, we call it as anions. Okay. Obviously, opposite charges will be getting attracted. So the cations, it shall move to the negative terminal. So the Pb2 plus, it is going to move to this terminal, and Br minus, it is going to move to this terminal. Okay. And now what you can understand, see this Br minus is going to positive terminal, Pb2 plus is going to negative terminal. Okay. So this rod, actually the cations, right? Actually, so Pb2 plus, it is a cation. Cation is moving to negative terminal. Remember one thing: the cations will move to, cations are going to move to cathode. Anions will be moving to, anions are supposed to move to anode. So easily you can make up, cations goes to cathode, anions go to anode. That is why the name also. So this terminal, that means this is the terminal, anion is moving, Br minus is moving to positive terminal. So the anode is going to be positive, and Pb2 plus is moving to negative terminal. That means a cation is moving to cathode. So cathode is going to be and negative charge. Okay. So remember, anode is positive, cathode is negative. This is a very important thing, very important aspect. Remember one more thing, and let's see what happens in the cathode and anode. In the anode, in fact, see, so I will mark it. So here it is, this is anode, this is cathode. This is anode and this is a cathode. Okay. Remember one thing, and anions will move to the anode, right? Anions will be moving to anode. So this Br minus, actually 2 Br minus. So when it is going to anode, Br minus, it is going to anode. Okay. So here it lost that 2 electrons. So it is going to be Br2, 2 Br, and cathode. Cathode, what will happen is, this Pb2 plus ions, it accepted 2 electron from cathode. Okay, because cathode is having, the electron flow is from negative terminal, right? So cathode is having negative charge, there will be electrons are there. So Pb2 plus, it accepts 2 electrons, and it is going to be Pb. Okay, so this only is happening, right? So in the anode, let me repeat, in the anode, a bromine is there, and cathode, lead is there. Okay, so these are the processes it is happening actually, so this is what it is happening. Okay. And this is the overall process of electrolysis, in which the electricity, when it flows, when it is flowing through the electrode, and the different products, it will be coming, and we will see what other molten compounds, how it is releasing, what are the other products it is generating. That examples also we will see. Okay. We have just told you how is the situation in which there is I told you other molten compounds also will be releasing the same releasing the products in the same way. For example, you see this is this is a battery, positive, negative. So you think that you are taking molten sodium chloride. Okay, so this is going to release Na sodium plus chlorine. These two gases it will releases. Sodium will be, as you can see, so this is going to dissociate into Na plus and Cl minus ion. So let this be the positive terminal and let this be the negative terminal. So anions, Cl minus, it will go to anode, right? So where is anions? Anions, it is going to go to anode, yeah, right. So this is the Cl minus will go to, this is positive terminal, this is nothing but the anode. This is actually cations, Na plus, this is going to go to Na plus, this is nothing but cathode. This is nothing but cathode. So what you can understand, this molten stuffs, molten compounds, molten ionic compounds, you can see in cathode, so actually cathode Na plus is going, right? So what is the product forming in the cathode is, metal will be forming in the cathode. In anode, non-metals will be forming. Okay, so Cl minus is a non-metal, and if you take potassium bromide, so this is going to release into K plus plus of Br minus. So yeah, in the cathode, like potassium will be the potassium will be going the cathode, and in the anode, yeah, right, actually anode, bromine will be the gas it is releasing in the anode. So this is the situation. So remember, any molten compounds, it will release respective products. Okay? If you are going to take KCl, so this is going to dissociate into potassium plus a chlorine gas. So potassium will be in the cathode, and chlorine, this is going to be in the anode. Okay, so this is how the products are coming. And now we have to consider another situation. I told you about the molten compounds, molten ionic compounds. Yeah, fine, molten ionic compounds only I said. But consider there is another situation, like, so this is going to be aqueous, NaCl aqueous solution, okay, or let it be NaCl aqueous solution. See here, aqueous means water, so this containing water. And so NaCl, this is going to release into Na plus Cl minus. H2O, this is going to release into H plus O2 minus. Yeah, you can consider O2 minus. Okay, H plus O2 minus. So remember, in this situation, yeah, there are two cations. Cations are okay, Na plus and H plus. These are the cations. These are the anions. Cl minus is the anions. O2 minus is the anions. Okay, Cl minus is the anion and O2 minus is the anion. And so here what is the thing is, like this cations, so there is a probability that these two cations, it can go to the it can go to the electrode, and there is a probability that there are two products possibility there. In cation, in cathode, cations, as it will go to cathode, right? So let's see the possibilities. Cations in cathode, like there is a possibility that sodium will be forming. There is also a possibility that hydrogen will be forming. Anions, of course, I'll write here. There is a possibility that chlorine will be forming. There is a possibility that oxygen will be forming. Okay, and so that is how the things it is going to come. And in the cathode, sodium and hydrogen will be forming. In the anode, so anions, it will go to anode. So obviously anode, chlorine and oxygen will be forming. So there is a possibility either oxygen will be forming or chlorine will be forming. In cathode, there is a possibility either sodium will be forming, either hydrogen will be forming. Okay, and so this is how the possibility comes. And let's see, in the aqueous sodium chloride, in cathode, actually chlorine will be forming. Hydrogen will be forming. In the anode, actually there is a chlorine gas it is going to form. In the subsequent sections, you will understand. Actually, in the subsequent section, you will understand why hydrogen is formed in the cathode, why chlorine is formed in the cathode, why not sodium formed in the cathode, why not oxygen has formed in the cathode. This particular aspect you are going to come across very soon. So let's wait. Okay. Let us see how the ions are preferentially getting selected in the anode and cathode when it is an aqueous solution. See, I told you, okay, we can take the example of sodium chloride itself. Okay, see, one thing, there is one particular concept called a reactivity series. You can see the reactivity series. Now. Okay, yeah. So in the reactivity series, you can see the position of hydrogen, and above that there are elements like sodium, potassium, and then lithium, there is of course magnesium, aluminium, zinc. But below the hydrogen, there is a reactivity series. Below that, there is copper, silver, gold. These are actually, of course, I'm not sure whether gold is there, copper and silver. So these elements are below the reactivity series. Okay. So one thing you need to know, it is very easy to find out in an aqueous solution which product it will be forming. See, for example, you check the sodium chloride solution. Okay. So this is going to dissociate into Na plus plus Cl minus, and as you are aware, H2O, this is going to dissociate into H plus plus O2 minus, 2H plus plus O2 minus. Okay, and what you can understand here, this one. See, there are two cations, Na plus and H plus. There are two anions, Cl minus and O2 minus. Okay, so these are actually the anions. And one thing what you need to understand here is, see, this sodium, it is a very reactive element. So if you see the reactivity series, it is just above the hydrogen. So whenever there is a tendency, the sodium, if you check the solution, okay, so sodium will try to remain in the solution itself. It will not come back as in sodium ion. And but on the other hand, H plus ions, it is very easy to reduce H plus ions. Okay, and so like this H plus ions, this is going to go to cathode. Fine. And this will release actually 2H plus plus, 2 electrons, so this is going to be H2. Okay, so this is going to happen with the cation. Suppose because you can see there are two possibilities, there are two cations, Na plus and H plus, but if you see the reactivity series, Na plus sodium is above the hydrogen, so there is sodium will not come to the cathode. Okay, sodium will remain in the solution itself. More reactive species will remain in the solution. And anions, there are two anions, and Cl minus and O2 minus. Okay, so this Cl minus and Cl minus actually this is going to be when it is a sodium chloride solution. Suppose if it is a very concentrated solution, just remember only one thing. If it is a concentrated solution, then Cl2 will form. Okay. If it is a dilute solution, then oxygen will be forming. So this is for a concentrated solution. This is going to be dilute solutions. Okay. Yeah, so this is what you need to understand. Okay, and on the other hand, if you take another solution, let it be silver nitrate, Ag plus plus NO3 minus. So if it is an aqueous solution, so in that case, cations present in the aqueous solution will be Ag plus plus H plus. So you can see in the reactivity series. In the reactivity series, actually, Ag plus is going to be silver is below the hydrogen, right? So there is a high possibility, the silver will be depositing in the cathode, so the silver metal will form. Okay, silver metal will be forming, H plus will not be forming. Okay, and so this is how how we can predict a product will be forming is you just check the electrochemical series, your reactivity series. If the element is more active than hydrogen, that will not come to the cathode. If the element is less active than hydrogen, that only will come to the cathode. Okay, and so if the element is more reactive than hydrogen, then hydrogen will be forming. Always the least reactive species will be forming in the cathode. More reactive species it is going to form in the anode. So